YouTube? Mr. King coming at you live from the studio. Oh, here are the questions for the day. Please pause the video now and answer them. So, hopefully you remember that elements want complete orbitals. They want to be full. They want a full ring of 8. Fluorine is closer to being full. It's closer than nitrogen to being full. So, since fluorine only needs 1 to be complete, it's going to be a lot better at just stealing that 1. That's why it's more electronegative. Nitrogen has to steal 3 to be full. So that's why it's a lot harder for nitrogen to get 3, because it's a lot more work. Whereas fluorine just needs 1, and that ring is very strong. It has a very strong pull since it's very close to the protons in the center. So fluorine's ring is going to be very strong, and it's only 1 electron away from being full. That's why fluorine is so electronegative. Yep, and then today you're going to demonstrate your knowledge of chemical bonds on a practice exam. Here's just what the final is going to be on. You don't need to do anything with that. You can just read it, put your name on it. Number 1, what are the different components of an atom? Explain the difference between neutrons, protons, and electrons, and explain where are protons and neutrons found versus where the electrons found. And this GIF is here to help you. The red and the blue are protons and neutrons. The green are the electrons. This is a GIF a student made. Okay, pause the video now and try number 1. Hopefully you remember that protons are positive, electrons are negative, why they're attracted to each other, and neutrons are neutral. I would have been very impressed if you remembered that neutrons and protons carry all the weight, almost all the weight in an atom. Neutrons and protons weigh 1,000 times more than electrons. You didn't have to put that, but I would have been impressed if you remembered that neutrons and protons are really the only heavy parts of the atom. Then the second part, explain where protons and neutrons found versus where electrons found. So remember, protons and neutrons are found in the nucleus. That's the inner ring. But electrons are outside the nucleus on the orbitals. On the orbitals or the rings. Yep. So if you got that protons are positive, electrons are negative, and neutrons are neutral, and you were able to tell me the different locations, you're able to do it. Okay? Number 2, please try and answer, how are elements able to make light? Use energy and electrons in your answer. The GIF is meant to help. Okay, pause the video now and try number 2. Hopefully you said, so if you look closely at the GIF, there's a little faint blue arrow that says energy. So atoms absorb energy, that's the first step. Then an electron will jump or move up to a higher orbital or energy level. So then the electron moves up. When the electron goes back down, when it goes back down, back to normal, that is when it releases energy, but the energy it releases is in the form of light. That's that last arrow. It releases energy, or light energy, just light. Something like that. If you were able to get number 1 and 2, put yes, you got it. If you missed one part or forgot something, put no. And if you need extra help, I posted some links to videos and an assignment that we went over it for. Yep. Number 3, you are a chemist studying 2 molecules, fluorine gas and sulfur gas. However, you notice that fluorine gas is extremely destructive. It does permanent damage on contact, but sulfur gas requires more prolonged exposure to inflict permanent harm. Research shows that elements that are very electronegative are so desperate for an electron that they will steal electrons from human flesh. Explain why fluorine gas is much more harmful than sulfur gas. Use electronegativity and electrons in your answer. So pause the video now, try and figure out why is fluorine more harmful. Hopefully you remember, based on the bell work, that fluorine is the most electronegative and it's extremely desperate to get an electron, and that's why it's so destructive. So if you talked about like fluorine gas is more harmful because fluorine is more electronegative than sulfur. So fluorine will try and steal electrons from everything it can, and that's why it is so deadly. Something like that. Just an explanation. When I'm reading it, I'm looking for electronegative or electronegativity and electrons in your answer. I'm looking for it to make sense. If you're able to find it, you're supposed to use the info in the question too to figure it out. If you're able to get the answer right, put yes. If you missed a part or didn't know or were stuck, put no. And then I posted a video and the notes assignment that we did that went over electronegativity. Last one, this one is going to be very tricky, okay? You are going to be doing some modeling for this one. Excessive carbon dioxide from pollution in the atmosphere, pollution that you get from like driving your car or from factories. So that releases a lot of CO2 in the air, and that CO2, carbon dioxide, mixes with water in the ocean to produce an acid, H2CO3, also called carbonic acid. Carbonic acid makes the ocean much more acidic and is killing off fish life and coral reefs. Diagram the Lewis covalent bond structures of CO2 and H2O. And when they go together, they make H2CO3. This last one, H2CO3, is going to be very tricky. It's an organic chemistry problem that college students will take. So don't worry if you can get this one. If you can get the first two by yourself, then you should be good. Yep. Pause video now and try the 3 Lewis dot structures yourself. At the very end, hopefully your diagrams look like this. Carbon dioxide should have 2 double bonds. Yep, and it looks like that. H2O, O is in the middle and it's bonded to 2 hydrogens and it looks like this. H2CO3 is very tricky. Don't worry if you didn't get this one. It has a double bond right here and then single bonds to these oxygens and then the H's are on the outside. That was the last one. If you got CO2 and H2O, put yes. If you didn't get the first two, put no. And I go over how to do covalent bonds in that video. And you can also check out the covalent bond practice problems. Yep. That is the last thing. After you finish the practice, please take the survey. Yep. Then you're all good to go. Bye, everyone.